All right, 10F notes here. I probably should have put these before we did 10E, but here they are. So we're going to talk about logarithmic equations that have extraneous solutions. Again, if we were to graph these things, we won't find extraneous solutions, but sometimes again the graphs are kind of hard to see, and so just taking a step back and talking about logarithms with extraneous solutions and how to sort of easily identify them. So if we have a logarithm with a log base a of b being equal to c, if the base a is positive, all right, if the base a is positive, then b cannot be less than 0. Okay, and it can't equal 0 either. Okay, and it cannot equal 0. I should put that there. All right. Now the reason being for this, so if we were to again rewrite this equation here as an exponential function, what it really is a to the c power equals b. Okay. So a to the c power equals b. So if a is any positive number, just say it's 3. Okay. If we raise 3 to a positive number, we're going to end up with a positive answer. Okay. If we raise 3 to 0, we know that's equal to 1. Okay. If we raise 3 to a negative number, we know that we're going to have 1 over a positive number. Okay. So however way we slice it and dice it, and I'm just sort of doing this as an example here. If the base is positive, then b cannot be 0 or negative. Okay. It cannot be 0 or negative. All right. So if a is positive, doesn't matter what c is, the b cannot be 0 or less. Okay. On the contrary, if we have the base a negative, so if our a value is negative, our base is negative, b cannot be greater than or equal to 0. Let's put that in there. Okay. Again, if our if our a value is negative, our b value is going to have to be a negative number. It cannot be greater than or equal to 0. So let's just do 4 quick examples right here. Okay. So here we have log base 4 of x plus 5 equals log base 4 of 4x minus 10. All right. With this equation, nice and simple, log base 4 of this, log base 4 of this. So we say x plus 5 equals 4x minus 10. All right. We calculate all this stuff. We minus the x and minus the x and plus 10 and plus 10. We had 3x equals 15. All right. 3x equals 15, and we have x equals 5. All right, so 3x equals 15, x equals 5. So what we're going to do is we plug the x back in here, and here. What we're going to have is we're going to have log base 4 of 5 plus 5, which is 10. Log base 4 of 4 times 5, which is 20 minus 10 is 10. And we don't have a problem because our base number is 4, and the number that we're logging is 10. 4 is positive, 10 is positive, so 5 is a legit answer for x. All right, coming to this next one here, we have x minus 6 and 2x minus 7, natural log of both, so we could say x minus 6 equals 2x plus 7. All right, we hammer out the math to solve this, and we get x equals negative 13. Okay. Now, here's the problem. We plug negative 13 in here and negative 13 in here. What happens is that we have the natural log of negative 19 equals the natural log of negative 19. It looks good on the surface. The problem is when we're doing the natural log, remember the base is e, which is a positive number. All right? Because we have a positive number e, this thing cannot be a negative. It cannot be 0 or negative. Okay? Which means that even though negative 13 is an answer, it's an extraneous answer. If we come over here into the calculator, we have natural log of x plus 6, or is it x plus 6 or x minus 6? X minus 6. And here we have the natural log of 2x plus 7. Here. Negative 13 was our answer. However, both of these graphs are not even going to come to negative 13. Okay? So it's going to be an extraneous solution because it doesn't exist. Okay? It doesn't exist. And there's not going to be a solution up here either. They're going to be parallel, all the way into infinity here. And they're never going to touch coming this way either. All right. So that x being negative 13 is an extraneous solution. They do not meet. All right. Moving on. We have a couple more here. I'm going to clear the screen here. So pause the video if you need to and go back. So here we have log base 9 of x squared minus 7x equals log base 9 of 30. All right. So we know that x squared minus 7x equals 30. All right. We can go do our quadratics and factor it, or we could just graph it in Desmos. However way we would kind of do this thing here, what we would end up with is x equals 10 and x equals negative 3. All right. So we go to plug these in. So if we put 10 in there, so we have 10 squared minus 7 times 10. All right, that would equal 30. No problem. If we plugged in negative 3 for x, we'd have negative 3 squared minus 7 times negative 3. Now, negative 3 squared is 9. Negative 7 times negative 3 is positive 21. So 9 plus 21 is 30. And so, again, we plug either 10 or negative 3. We get 30 in for this thing here. All right. We get 30 in for this. And so there really shouldn't be a problem. If we go to graph it, where is it? Okay. So we have log base 9 of x squared minus 3x. And then we come down here, we have log base 9 of 30. Like that. All right. So we see we have our logarithmic thing right here. Did I not type that in right? X squared minus 7x. Whoops. X squared minus 7x. All right. So we plug that in there. We get one x value where they meet at -3. Other x value where they meet at 10. All right. A little bit of a funky problem right here, and we're not going to talk about these functions a whole lot, as we see this one kind of just dies right here at, right around 7 or so. And the other one just sort of flat line right there. So this one here, log base 9 of that, log base 9 of that. We have two answers, we have two solutions, and it matches the math, okay? Because we solve for 10, we plug it in, we get positive 30. We solve for -3, we plug it in, we get positive 30, which is fine because we need a positive 30 right there. All right, the last one. Here we have log base 5 of x plus log base 5 of x minus 4 equals log base 5 of 21. All right. Now, when we're adding these two logs, which we are here, again, our logarithmic rules that we talked about, we're going to put these back together and multiply. So because we're adding these two things here, we can come in here log base 5 of x times x minus 4 all inside that thing is equal to log base 5 of 21. All right, simplifying this down, we have log base 5 of x squared minus 4x is going to be log base 5 of 21. Okay, so again, these two logs are adding, this log and that log are adding. So we take the x and the x minus 4 and we multiply them. Okay, so we get x squared minus 4x equals 21. All right, if we were to solve this out, again, we could factor or we could graph or what have you. I'm just going to go in here and graph. So we have, here we have y equals x squared minus 4x. Here we have y equals 21. All right, so we have two answers, -3 and 7. So -3 and 7. Again, pause the video if you need to. I'm going to go kind of fast here. So x equals -3 and 7. Okay? If we plug -3 in, if we plug in -3, what we're going to have is we're going to have log base 5 of -3 and then log base 5. All right, -3 minus 4 is -7 equals log base 5 of 21. Now on the surface that looks okay because the -3 times the -7 is 21. Problem is that we have log with a positive 5 getting to a -3 and a positive 5 getting to a -7, which we can't have. All right, we can't have that, so that scratches -3 out there because we can't have a positive base with a negative answer after it. It's impossible. Can't do it, as we sort of showed above. Okay, if we have 7, all right, then we have log base 5 of 7 plus log base 5 of 3 equals log base 5 of 21. Now we're fine here, okay? The 7 times the 3 is 21, so we're good there. And we have a positive 5 to a positive 7 and a positive 5 to a positive 3. So because we have that, we're good to go. Positive, 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 everything matches up. So our answer there is going to be x equals 7. So -3 is extraneous. So -3 works when we do the math, but when we actually find out what would actually exist, -3 is out. Okay. So if we were to graph this thing here, so y equals log base 5 of x plus log base 5 of x minus 4. There's our graph here. On the other side, we have y equals, what was it? 21, log base 5 of 21. All right. We see we have one solution. All right. One solution at 7. If we come over here to -3, where our other solution is, clearly it doesn't work because the graphs don't match up. So 7 is a real solution. -3 is not. All right. So take the time here. So we got the 4 example problems done here. Take the time and work the extraneous, solve these and work for extraneous solutions. On these bottom ones, just do 37, 38, 41, and 42. Rewind the video if you need to. If you have any questions, let me know. And you can always graph these to check. Thank you and have a good day.